Experiment No.1 Tensile Test on mild steel. Aim to conduct tension test on ferrous and non-ferrous alloys, mild steel, cast iron, aluminium, etc., and determine the following. 1. Yield stress 2. Ultimate stress 3. Breaking stress 4. Percentage elongation 5. Percentage reduction in area. Reference is 16.8 method for tensile testing of steel products. Apparatus, universal testing machine, test specimen, steel rule, vernier calipers. Theory. The tensile test is most applied one of all mechanical tests. In this test, a test specimen is fixed into grips connected to a straining device and to a load measuring device. One end in stationary grips and the others are in movable grips. If the applied load is small enough, the deformation of any solid body is entirely elastic. An elastically deformed solid will return to its original form as soon as load is removed. However, if the load is too large, the material can be deformed permanently. The initial part of the tension curve, which represents the manner in which solid undergoes plastic deformation, is termed as plastic. The stress below which the deformation is essentially entirely elastic is known as the elastic limit of the material. In some materials like mild steel, a sudden drop in load indicating both an upper and lower yield point denotes the onset of plastic deformation. However, some materials do not exhibit a sharp yield point. During plastic deformation at lager extensions, strain hardening cannot compensate for the decrease in section, and thus the load passes through a maximum, and then begins to decrease. At this stage, the ultimate strength, which is defined as the ration of the load on the specimen to the original cross-section area, reaches a maximum value. Until this point, the deformation is uniform at all the sections of the specimen. Further loading will eventually cause neck formation and rupture follows. Usually a tension test is conducted at room temperature. The tensile load is applied slowly. During this test, either round or flat specimens may be used. The load on the specimen is applied mechanically or hydraulically, depending on the type of testing machine.
वेट असेल ठीक आहे 670 ग्राम ठेव बसना ठीक आहे ते डायरेक्ट दिसले पाहिजे पाचशे झूम कर झूम जवळ आलं तरी चालेल
Observation. 1. Nominal stress and nominal strain. Original CS area, A0 143.139 millimeters to original gauge length, L0 DJ millimeters. Weight of the bar EPE 0.3375 kg. Increase in gauge length, line 0, OT, 15. Nominal stress. A nominal load to original CS area. AG, 120, X, 100 draw, 43.13, 90 takes A, 838.35, NM22, nominal strain G-wall 0, IT 300, 0.0267. These are diagram of universal testing machine and stress strain diagram for mild steel. A universal testing machine, UTM, is a device used to test the mechanical properties of materials under tension, compression, or bending. It consists of two main parts, the loading unit, which applies the force, and the control unit, which measures and records load and deformation. The UTM helps determine important material properties like yield strength, ultimate strength, and elongation. The stress-strain diagram for mild steel starts with a linear portion, where stress is directly proportional to strain, obeying Hooke's law. Beyond this, the curve reaches the yield point, where the material begins to deform permanently with little increase in stress. After yielding, the stress increases again until it reaches the ultimate stress point, representing the maximum load the material can bear. Beyond this point, the curve drops slightly due to necking, where the cross-sectional area reduces significantly. Finally, the material fractures at the breaking point, marking the end of the test. 2. Limit of proportionality. Stress is proportional to strain up to this point. Normal stress, HE normal load, original CS area, R114, X, 143, 143. 0.98 T 296.43, NMN2, normal strain. Away low 7. Then the dimwin 300 seroturon 0233. Elastic limit. When the load is removed at A, the specimen will go back to original dimensions, nominal stress, EGPAO, or original. Original CS area. R114. 103, 143.139T2, 796.43, NMMT2, normal strain. Low B, low 7, 300, 0231. If the specimen is loaded beyond elastic limit, it will undergo permanent strain, in other words, plastic deformation. 4. Upper yield point, nominal stress HEBAO. Nominal stress, upper yield load, original CS, area, Q120X, 103 100, and 43 139 CJKA, 35. NMD2, nominal strain day, Lodilo 8300, 0.02675. Lower yield point. Nominal stress, HE, EOO lower yield log, original CS area, 18. R100, 143. 0.39 check 824.37. NME2, nominal strain, AAEC, low 75, 300. NME2, nominal strain, AAEC, low 75, 300, 0.025. 025. X, ultimate load or maximum load point, nominal ultimate stress HPDAO, maximum load, original CS area, EC, 124, SAIL 103, 143.319 page 866.29, NM2, nominal strain, low D, low, 26 300, Tection 60.687, Fracture load point F. Nominal fracture stress BPAA. Fracture load original CS. Area Co 122 X 103 143.290 18 Chakatua 1852.32 NMNT2. Nominal strain at fracture weight 27,300.0909. 8. Young's modulus. E. Young's modulus. EK stress. Strain 120 series 0.0. 267 Chichi 44.9. 4. 3. 8202 x 105 NMT2 and 9. Yield point elongation. Elongation taking place in the specimen from C to D. This is taking place without increase in stress. Percentage elongation OW. Final length. Initial length. X 100 initial length OKC. 315. 300. X 100 300 ATI 5% percentage reduction in area. Original area. Reduced area. X 100 original CS area. 143.39. 78.539. X 100 fray. Procedure. 1. Measure the original gauge length, weight, and diameter of the specimen. 2. Insert the specimen into grips of the test machine. 3. Begin the load application and record load versus elongation data. 4. Take the readings more frequently as yield point is approached. 5. Measure elongation values. 6. Continue the test till fracture occurs. 7. By joining the two broken halves of the specimen together, measure the final length and diameter of specimen at fracture.
खालून
Results. Tension test for given specimen was conducted, and the results are as follows. 1. Yield stress H8 838.35 nmt2n. 2. Ultimate stress 866.29 nm2. Breaking stress H8 852.32 n ma24. Young's modulus OCAL 44.9 4382202 x 100